In section P9, we're going to learn about a new type of way to write inequalities. This is what is frequently used in upper level math classes. It's a little bit less cumbersome of a way to describe an inequality or an interval. And so it kind of makes your life a little bit easier, I think, but it is going to be new. So interval notation uses parentheses and brackets to show what our upper bound and our lower bound is, okay? So here's the main things that you need to know when you look at an interval. It's almost going to look like an ordered pair. You're going to have either a parenthesis or bracket, and on the left is going to be your lower bound, and on the right is going to be your upper bound. Sometimes there may not be a bound on one side, and that's when we use infinity. So if you see parentheses, that means not including. So if I see parentheses on the number, that number is not included. That's the equivalent to less than or greater than. If I see brackets, that means that you are including the endpoints. That's the equivalent to less than or equal to or greater than or equal to, okay? So let's look at what that looks like. So when we're looking at interval notation, if I have parentheses on both sides, meaning I'm not including the endpoints, we call that an open interval. And that represents the set of all the numbers between but not including A and B. So this is how you would see it written using set builder notation. And you can see here that we've got this compound inequality. A is less than X is less than B, okay? This is how we would write that same inequality using an interval. And if we look at the graph, you can think about what that means. That means that A is our lower bound, and we want to include everything up to B, which is our upper bound, but the parentheses show that we are not including the endpoints, okay? The opposite of that is a closed interval, and the closed interval includes everything between A and B, and it includes A and B. So in inequality notation, we've seen it like this. A is less than or equal to X, less than or equal to B. Notice that the interval now has square brackets on each side. That's how we show equal to. And on the number line, we just put brackets on the end to show. In Algebra 1, you used an open circle and a closed circle to show open versus closed, but we use parentheses and brackets now, okay? So this includes A, includes B, and it includes everything in between. All right, now, an open interval has parentheses on both sides. A closed interval has brackets on both sides. But it is possible to have an interval where one side is included and the other side is not. That wouldn't be called open or closed. It doesn't have a specific name. But it is possible that you're going to have intervals that are mixed like that. Now, not all inequalities are going to be a between inequality like that. It might just be greater than or less than. And if that is the case, then that means that your upper bound is either going to be infinity or negative infinity, okay? Now, here's something that's really important. When you are writing your intervals, you see on this second example here, where we have X is less than or equal to B, we can be equal to B, so that's why we used a square bracket on this side. But this is important. You never put brackets on infinity. Because infinity is an idea. It's not a number. We can't actually get to infinity because we could always just go one step more and be at a bigger number. So you never put a bracket on an infinity. Negative infinities will only ever go on the left because that's the lower bound. Positive infinities will only ever go on the right. So in an infinite interval like this, where if I just said X is greater than A, that means that I can be A or bigger. So A, but not included, that's why there's a parenthesis, is our lower bound. That's the smallest number we'll ever approach. and positive infinity is our upper bound. Okay, versus if it's less than, then that means that the lowest, we can go all the way down to negative infinity because it's anything less, that's your lower bound, and greater than or anything greater than that, we have to stop at B. All right, so here are some examples of intervals that we want to rewrite using set builder notation and then sketch a graph. There's a couple of typos here that you'll have to look out for. On number 1, there should be a comma between these two numbers. And on number 2, this first period here should also be a comma. It's 1 to 3.5. So number 1, because I don't have an infinity, that means I know where I start, I know where I stop. I know A and B. So that's going to be a between inequality. So in set builder notation, remember we always start with the same, whoops, I'm in the wrong spot. We always start with the same setup. It's going to be all x's such that. That always has to be at the beginning of your set builder. So it's got to be all x's such that x is between -2 and 5. And then we just need to decide, can we be equal to -2? Yes, we can, because on that side it's a square bracket. So we want an equal to. But we cannot be equal to 5 because on that side it is a parentheses. So that is what our interval would look like. These compound inequalities like this are always written from least to greatest. So these will always be less than symbols. Lower bound on the left, upper bound on the right. When we go to graph this, it's really easy. -2 is our lower bound, and we can include that, so we want a bracket. +5 is our upper bound, but we cannot include that, so we want parentheses. And then we shade in between. So I'd like you to put the video on pause and see if you can do examples 2 and 3. I'll post the answers in 3 seconds. All right, here's what your intervals should look like. On number 2, both of the inequalities are brackets, so that's why we include the equal to. And so we shade in between, like you can see on the graph there. Number 3 is one of the infinite intervals. And on your number line, remember always that negative infinity is going to be on the left side and positive infinity is going to be on the right. So when we shade it, we have to shade in the arrow because we go through negative infinity as far as we can go. And then we have our parentheses at -1. Okay? So intervals also represent sets. So it's kind of a different way to write a set of numbers. It's everything included in that interval, which is why we can rewrite it in set builder notation. So we can also look at operations using these intervals like we did with sets. So we can find the intersections and the unions of intervals. So if you can do this without a number line, that's great. But I'm a very visual person, and it's helpful to see the number lines, I think, to make this kind of click here. So for number 4, we want to find the intersection of the interval from 1 to 4, open, and the interval from 2 to 8, closed. So here's how I like to do it. I like to do it on the same number line. So here's my number line, but I'm going to graph one kind of above the number line and one kind of below. So my smallest number is 1 and my biggest number is 8. That's looking across both sets. So I know that I need to go maybe from, say, 0, here's 2, here's 4, here's 6, here's 8. Okay. So above the line, the interval from 1 to 4 is going to look like this. And below the line, the interval from 2 to 8 is going to look like this. We want the section of the number line that they have in common. So the place where they overlap, if you kind of drop down, is this right here. Okay, so we know that we've got this shaded area in between 2 and 4. We need this point to be included in both. So if we look at the top, at 2, I have the line, so it's definitely included. And below, I have a bracket. So that means that 2 is included, and we want to take a bracket on this side. But for number 4, I have the line, so it's included here, but it is not included in the upper interval. So we cannot include it in ours either, because remember, an intersection has to include all the values that are in both sets. So that means the intersection is from 2 to 4, where 2 is included, but 4 is not. Now, you might be able to figure that out without looking at the picture, and that's fine. However, you can get there. If once it kind of starts clicking, don't sketch them out anymore if you don't need to. Now, if we were doing a union there, the union, this is not what it asked us, but the union would be smash the 2 together. So we would get the whole distance from 1 to 8, and then we would decide, do we keep it or not? So on this bottom one, we would take the parentheses, and on the top at the 8, we would take the bracket. So I'd like you to put the video on pause and try number 5 and 6 on your own. Answers in 3 seconds. All right, so the answer for number 5 should be from 2 to 3, 2 not included, 3 included. That's very similar to number 4. Now, number 6 is those same 2 intervals again, but this time we want to look at the union. So all we need to do, we need to go from the furthest to the left and the furthest to the right, including where they overlap, but also where they don't. So this one, we would bring the bracket down to 1, and here we'd bring the parentheses up to the 6. And so that's our union. That's everything that is in either one set or the other. And so that will be from 1 to 6. Okay. The last thing is that as we saw with equations, we want to present our answer as a solution set. And so now with inequalities, we want to be thinking about this in the same way. So you always want to give your answer in an interval. We're going to very rarely use inequality symbols from this point on. Okay. So the other thing to remember about inequalities is that when you divide or multiply by a negative, you have to flip the direction of your inequality arrow. So for number 7, this one is pretty straightforward to solve. We'll start by subtracting 3. So we get negative 2x is less than or equal to 8. And then we divide by negative 2. And because we divided by negative 2, we have to turn the inequality sign around. Okay? So there's our solution as an inequality. Now to write my solution as an interval, it says that x has to be greater than or equal to negative 4. So I can have numbers bigger than negative 4, which means negative 4 is my lower bound and positive infinity is my upper bound. If it helps, sometimes I think it's easier to graph it first. We know how to graph x is greater than negative 4. And so when you see the graph, you can see that positive infinity is your upper bound. So sometimes that is helpful. So again, please pause the video, try examples 8 and 9, and then come back here for the answers in about 2 seconds. All right, here are your answers. You ended up needing to switch the sign on every single one depending on how you set it up. And so those are your intervals and graphs. So these intervals are new. They're just going to take a little bit of practice. So doing your homework and using the tools on my math lab is really going to help you get used to this. And we're going to continue practicing this in the next video.